Okay, welcome to our project presentation entitled SurvPlant Edible Plants for Survival. Okay, without further ado, let's start the presentation.
Okay, our background in building application is edible plants in the forest are often ignored, yet they can be life-saving in emergency. Current tools struggle to identify plants in various conditions. Our goal is to create a solution that helps people quickly and accurately recognize edible plants, ensuring safety in critical situations. Okay.
Okay, why we choose this theme? Because in the modern times, many people live in the urban areas. It is far from nature, so it is unlikely to know the plant that exists in the nature. So we want to develop machine learning based on the detection to identify plants that are safe to eat. The system developed can identify quickly and accurately. The system will be useful for everyone, especially for mountain climbers or adventurers who are in the critical condition or urgent situation. Next, we go to the data. In the India, deliberate self-poisoning is the rate is 8.2%, and dominating by a woman is around 16 to 30, and the data by hospital, the death rate is 9.3%. It based on the Indian Journal of Critical Care Medicine. In other case, in the UK, case costs of death to, to plants are quite low according to the National Poison Information Service. Even in 2060, in the UK, plant poisoning was not included in the main category of fatal case. But it, even though the data show a low percentage in the two country, this is still dealing with someone's life. So meaning that it is still a problem. So the hope is that with this application, it can be spread and reduce case caused by unsafe plant.
Okay, so this is the existing result. Some application already exist such as PlantNet and iNaturalist, but they are less accurate in recognizing plants in tropical areas, especially in Indonesia. In addition, this application cannot provide complete information on the brief nutritional content of each plant. He wants to improve accuracy and provide more detailed and better data. As seen here, SurvPlant has features that other applications do not have, such as focusing on edible plants, providing nutritional information, and being optimal on low power devices. Next. This is the implementation of our product using website so it can be responsibly accessible. Next. Implementation in machine learning. In creating a model for our project, we use a pre-trained inception feature to solve the case of classifying edible plants classes, and also use a type of artificial neural network, namely CNN, to process and recognize image, which after the model is finished, we save in JSON and bin format for use on the web. Next. For now, our model can recognize 32 edible forests, plants, and also along with brief information in the form of description and nutrition for each plant that is successfully detected. Next. Here is a image of each class of plants, and in building the model, there are some that we improve because the previous model
was less able to learn optimally from the dataset. Since then, we decided to use pretend learning or transfer learning to speed up training while helping to improve accuracy and reduce overfitting. The changes are not only that. The rest of improvement can be seen on this slide. Next. Before the model finish, our model goes through several stages of the process, namely exploratory data, data processing, and data modeling. And the end, our model gets a training accuracy of 93% and in the test accuracy of 87%. Even so, our model is quite good at generalizing image. Next.
After you are talk about the fun project that we are using the Google Cloud platform. We use Google Cloud platform to host the project in Proyek. I will explain what the fees we use on the Google Cloud platform. Next. Can you see that there is a diagram to show what the fees we do? Are App Engine, Kotra, and Cloud Storage. I will explain a little about each service. First, we use the App Engine to deploy the front end of the website that has been created. Because our ended magnetic, the alternative is to create it via the website. Next, we use Cotral to deploy the backend application to process the model and APR. And finally, Cold Storage is used to store models that have been prepared by the MLT so that they can be accessed by the public and at backend application. Next. And with the REST API architecture, the user via the front end will send a request for a limit with the intel tag and with the first method which will be processed by the backend application. Then the backend will send a response in JSON format as in the above. The JSON will be displayed on the front end that the user access and provide information on the plan image that have been set. Like
Okay, and this is a demo of our project. You can find our SurvPlant project at the following GitHub link in this slide. Next. In the next 6 months, we also plan to continue our project to the next stage by covering a wider community, especially in Indonesia. For the stage can be seen from our roadmap. Next. And here is our budget that we have calculated for our project. Next. 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 That's the presentation for from our team. That's all and thank you.